This is a video from eSkills Zone. For more videos, notes, and certificates, please visit www.eskillszone.com.
Hello and welcome. Hi viewers. Today in this video we will discuss a program which displays a happy face on the screen. So this is actually a final circle program. So I'm going to write it here, a final circle program. Uses both complete circles and partial circle. So let's switch to the IDE where we will execute this program and see how it is done. So viewers, in line 10 we will type RAM statement. Likewise we have been mentioning in our previous programs. Line 20 we will type RAM and type space asterisk happy and asterisk. Line 30 we will type RAM space asterisk. This program draws a happy face. Line 40 we will type RAM and then asterisk throughout. Line 50 we will type screen 1. Line 60 we will type color 5,1 foreground background color. Line 70 we will type RPD again, radians per degree with single precision, sign exclamation symbol. The value is 0.0174532. Line 80 so we can type we'll type CLS in line 70. In line 80 we will type RPD, sign of exclamation and 0.0175174,532. Line 90 and here we can type apostrophe and then type. This apostrophe is also works like RAM statement because it is used to display any remark in the program. So we'll type radians per degree. This variable, single precision variable, is actually used to convert the radians into degree by assigning the value, this value, into this variable. So this will be helpful for converting the radians into degree. So we have mentioned a comment just in front of it, and this apostrophe will make this radians per degree statement into a non-executable statement. Line 90, because remark is always in non-executable statement, circle 160, 100, 70, 30, 3. Line 100 circle statement again used with x and y coordinates 135, 80, 10, 1. Line 110 circle 185, 80, 10, 1. Line 120 circle statement 160, 110, 30, 1, 180 into RPD, sign exclamation, 360 into RPD. Line 130 we will type E and E end. Now press the enter key and we'll press the F4 key to save this program. We'll type happy face dot bs, name of the file. We'll press the F2 key So now you can see happy face on the screen with the help of this circle statement, which is the last program of circle statement. So we will now switch to the text area where we will explain the interpretation of the whole program line by line. So let's switch to the text area, viewers. So viewers, now we will work in the text area where I'm gonna explain the whole interpretation of this program line by line execution. So that was the program actually, starting from line 10 till line 130, and that is the output of the program, smiley face on the screen. I'm going to interpret this program, so let's see. So let's start its interpretation, how this program is actually interpreted. As we can see, working with circles takes a lot of planning and careful typing. That's true. If we have trouble, try working out the diagrams on graph paper. First, remember that circles are drawn counterclockwise. So we have discussed earlier in our previous videos. Find the points on the edge of the circle where you want to start and end. Review all examples. Think like a computer and draw some of the circle commands on graph paper. Make sure all the commas are in the right places. Very important point to be noted. Above all, experiment. Build your programs slowly. Run a program each time you create a circle. Statement. Then you can catch mistake as soon as it happens. Don't write a dozen circle statements and then try to find the one that is not working as you had planned. Now we have discussed that since you can see that line 10 to 40 contains RAM statement, and in line 50 screen 1 statement is used that will display the output in graphical mode. In line 60 color 5,1 used, which will display the foreground and background colors on the screen. In line 70 CLS statement is used to clear the contents of the screen. In line 80 RPD is assigned value 0.01745332 using assignment operator equal to symbol, and a remark is added using apostrophe. Radians per degree, which is actually used to convert the radians into degree, because we always need the values in degrees, whereas the starting and the ending points are calculated in radians. So in order to convert the radians into degree, we use this formula that we always need to assign the value of radians to degree by assigning this value to the variable RPD single precision, because we have used this RPD in line 120. In line 90 circle statement is used with x coordinates 160 and y coordinate 100, having with radius 70, having color 3. Again we will paste this line, copying pasting. 100 circle statement is used with the x coordinate 135 and y coordinate 80, with radius 10, having color 1. In line 110 circle statement is once again used with x coordinate 185 and y coordinate 80, with radius 10, having color 1. In line 120 circle statement is used with the x coordinate 160 and y coordinate as 110, with radius 30, having color 1. Starting point 180 into RPD sign of exclamation used as a single precision variable comma, ending point 360 into RPD line 130, and statement is used to close terminate the main GW basic program. So viewers, if you can see that over here, you can see this is the program, and when after assigning this particular value, which is used to convert the radians into degree, which is used in line 120. So this is the first circle which was drawn with 160 and 100 having the biggest radius and having the color 3, and that is the So viewers, you can see that this very circle in line 90 was used with the biggest radius 70 value. So this is actually used to draw the outline, the biggest circle, the bigger one of all, in white color by using the circle statement. X coordinate is the coordinate which is starting from over here, and Y coordinate is value is 100, which is starting from here. So you keep it in your mind, the circle is always drawn from counterclockwise. So this circle is actually drawn like this way. So if you see line 100, circle statement is again used, but here the X and Y coordinates are 135 and 80, and the value is 10 and 1. So this actually circle is used to draw this eye on the screen. So you can see the radius is very small as compared to the one used in 90. So radius is 10, so you can see a smaller circle over here, but here the value of X is 135 and the value of Y coordinate is 80. Since you can see in line 110, you can again see the same radius having the value of 10 and color as 1. So this is again, you can see a blue circle, because here 1 and 1 is used, which is used to draw a circle in blue color, and the radius is again 10, which means that the same size circle, like the one eye of left eye, you can see the other eye of the same radius having the same radius, same circle is drawn, but here the values of the coordinates are changed, which are again 80 and 185. So the value of Y coordinates is 80 and 80. You can see the same 80 and then 80 over here, but the value of X coordinate is 185, so it's actually drawn from over here. So it is a little farther. There is a distance between 135 and 50, and you can see the distance of 50 pixels can be seen. So if you start counting over here, you can count total 50 pixels. So you can see the other eye over here. With the help of line 110 statement, we can see the other circle having the same radius 10. So the last circle, which is a half circle, not a complete circle, is used with the, which is also called a partial circle. You can see the values. The coordinate X coordinate is 160, so it starts from over here, and then the Y coordinate is 110, so little below the other coordinate. So over here it actually drawn from over here, and then having the radius 30 more than 10. So you can see this one circle was drawn with, these two circles are drawn with the radius 10, and this circle was going to be drawn, fully drawn, with the help of radius 30, with having the same color 1 blue. But since we have used RPD with 180 and RPD with 360, we have used these two values 180 and 30 as starting and ending point, so we can never see a complete circle over here, because if we have used 360 over here, we can see a complete circle. So let's switch to the IDE. We will change the value from 180 to 360 and let's see what happens if we had used 360 over here. What would happen? So let's see what would happen if we had used 360 instead of 180, because this 180 will actually draw the circle into halves, or you can call a partial circle. So let's switch to the IDE, viewers. So viewers, if we change the value from 180 to 360, then you can see, and the value from 360 to 180, you can see an opposite, an angry face on the screen, or you can call a bad smiley face on the screen, not a happy face on the screen. In order to draw a happy face, we must have used value 180 over here starting point and 360 over here as the ending point of with circle statement. That's all, viewers. Thanks for watching.